Find integers that are upper and lower bounds for the real zeros of the polynomial. So pretty much what I'm doing, this will help. Let's say I have these zeros right here, and I have a bunch of things I need to check. And if there's too many things to check, I can actually find upper and lower bounds in which I only need to check in between those upper and lower bounds, which means I don't have to check everything, which helps out. So let's find a lower bound. Now, in order to use the upper and lower bound theorem, remember the lower bound has to be negative. So pretty much our lower bound, if I want to go have an upper and lower bound, so I want all my zeros to be between A and B. First of all, A has to be less than 0 and B has to be greater than 0. So the first integer that's less than 0 is -1. So let's check -1 and see what happens. 1, -2, 1, -9, 2. So this gives me 1, -1, -3, +3, 4, -4, -13, +13, 11. Now if you notice, it switches signs every single time. Now if it switches signs every single time, and this is negative, then this will be a lower bound. So let's try to find an upper bound. So my next integer is going to be 1, because 0, we can't use 0, because remember, for an upper bound, we have to have b bigger than 0. So then I get 1, -2, 1, -9, 2. This becomes 1, and then 1 times 1 is 1, -1. -1 times 1 is -1, 0. 0 times 1 is 0, -9, -9, -7. Switches signs right there, therefore it doesn't work. Let's try the next one. So we're going to try 2, so that doesn't work. 2, 1, -2, 1, -9, 2. 1, 2, 0, 0, 1, 2, -7, -14, -16. Now, if you notice, doesn't switch, it switches. So that one doesn't work. So the next one we're going to try is 3. So 3, 1, -2, 1, -9, 2. 1, 3, 1, 3, 4, 12, 3, 9, 11. So, if you notice, it doesn't change sign at all. Since 3 is positive, then that means 3 is my upper bound. So all my zeros are going to lie between -1 and 3. And that is the answer that I want to get for this. So A is -1, B is 3. The reason that this will help in a normal problem is if you use the rational root theorem, you'll get plus or minus 2 and 1 all over 1. Since -1 is a lower bound, -2, I don't have to check -2 at all. I also don't need to check -1 because I've already checked it, which means the only two that I need to check are 1 and 2.